Okay, so hello everyone. In this video, we will be solving the question number 3514, which is the count the number of unique XOR triplets, part 2. It is marked as medium. The question is very easy to understand. The brute force is also a very common thing that everyone will get, but the main thing is the constraint. So as a result, we may need to find and turn around, which could help us to bypass the brute force by some twist, and as a result we may solve this question. So yeah, let's first understand what the question is about, what is the constraint, and as a result what we need to change and how we can do it. So yeah, let's start. Okay, so let's understand the question. We are given an integer array nums. Okay, a XOR triplet is defined as XOR of three elements, which are nums I, nums j, nums k, where I and j of I, j, k follow this given relationship. Return a number of unique XOR triplet values formed after all possible triplets I, j, and k. Okay, so let's first understand that we will be given a nums which will contain x, y, a, b, e, g, and we need to form triplets and return the distinct XORs found. We are also given I less than. Is this to be considered? So is this given criteria need to be considered? Because you can think that if we want to form a triplet and satisfy this I is equal to j less than equal to k, you can say that we can form any any triplet. If suppose one takes I as g, j as x, and I, j, k as a, so it won't satisfy the given fact that I less than equal to j less than equal to k, because j is here, sorry, I is here and j is here, so I must be less than equal to j. But what happens if we take I as x, j as what you can see a, and k as g? So as a result we can form all triplets. So I can say that this should not be considered. Okay, this what you can say given condition is not at all to be considered. Now if we want to form triplets, the first intuition will be for I equals to 0, for j equals to I, for k equals to j. But we are also given that nums dot length less than equals to 1500. So suppose let it be 1000, which is 10 power 3, and this brute force will be of n cube. So 10 power 3 star 10 power 3 star 10 power 3, which will give 10 power 9, and 10 power 9 greater than sorry greater than 10 power 8 is equals to 1 second, so we will get TL. So this of n cube, thus of n cube won't work. So of n cube won't work. So how do we have to move or move forward with the approach? So let's first understand one thing. Suppose okay, this is index 3 2 0. Okay, if we want to represent phi, how will we represent it in bitwise operation? So phi can be represented like phi can be represented using 1 0 1. Okay, 4 3, it would be 1 1. Okay, and if we do that XOR, what we get is 1 1 0. Okay, so you might have found that even though there was nothing, or if suppose there was something, let's suppose here it would be 7, the answer would be, so we can say that number of bits do not increase in the answer. Here the number of bits were 3. The answer also consisted of 3 bits. If there was a 3 here, then there would be 1 1 0. So even here it was 3, here it was 2. So the maximum of them, which is 3 prevailed. So you can say that XOR does not append nor what you can say decrease the number of bits. Okay, this is one of the key learnings that we will consider. Let's take an example. Let's take 1 2 3 4. Okay, if we form one triplet as 1 1 1 2 3 4. Let's form one triplet 1 2 4 and another. Okay, we'll form another one. 1 can be represented as 4 can be represented 1 0 0. 2 can be represented as 1, 0. And 1 can be represented as 1. So when we do the log XOR, we get that it is 1, 1, 1, which is 7. Let's take one more example of what we should take. We should take 4 and 3. As of now, it is just a pair. 1, 0, 0, 1, 1. So their XOR will be 1, 1, 1. So we can say that if the largest element had m bits, largest possible XOR has all m bits set as 1. 4 has 3 bits, therefore m equals to 3. And largest possible answer was also 7, which is represented as 1, 1, 1. All 3 bits are set. What is set? Set is nothing but a 1. Set bit is nothing but 1. Okay. So from this, what we have from this, largest possible answer is 2 power m minus 1. If the number of bits set bits were 3, so the answer was 7. If the number of set bits were 2, let's take it. M equals to 2, so the answer was 1 and 1, so it would be 3. Okay. Largest possible answer is 1. Okay. But now what to do? There was one thing which was creating a bottleneck in these 3 loops, was the fact that when we form pairs, like suppose okay, so now what to do? After finding it out that largest possible answer is 2 power m minus 1. Now what we should do? Now we need to think about one approach. The main thing, instead of doing of n cube, why don't we do it like of n square? And then of n square, like suppose in for I equals to 0 till I less than n, and for j equals to I, spell j less than n, and also we get XORs of all pairs, and then do XORs of all pairs with all nums are. So what I will tell you is that suppose we have A, B, C, D. Let's take four numbers as of now. All found pairs will be A, A, and then A, B, and then A, C, then A, D. B, C, D, and then C, here it would be B as well. Here it would be C, C as well, and D, D. Okay. Now what we have done after this? Why don't we just do the XORs of each pair? XORs of each pair with each element once again. So, like, instead, do XORs of all pairs with each element of nums, like this. Okay. But you might have found out that in this process many duplicates have been formed. Like if we create this properly, it would be B, A, or suppose leave it. It may be possible that A, B, and C, B will yield the same output because A will give 0 and 0, B will give B. C, would yield 0 and 0, B will give B. So what we have done is we will be repeating and same XOR will be done. So it may take more time, or for better understanding, let's take another example. A, B, C, C. This will yield 0, this will yield 0, and this will yield 0. And after like doing the XOR of A, with all XOR of B, with all XOR of C, with all will give same answer because these pairs will contribute nothing, or the same thing, which will be calculated with these elements once again. So as a result, we are repeating the XORs. So why don't we just do XOR of 0 with all elements? So why don't we just do that? Right? Then how we should maintain that? Instead of using 0 3 times, we should use it one time. So what I'm thinking is, let's first store what we have. How to get rid of it. So what we should do is store the outputs of XORs of pairs in a set. What will set do? It only stores unique values. No nuclear case. So what will happen is, for a comma a, it is given 0. It will be stored. For b comma b, it will be 0. It will be checked. It is found. So no condition. C comma c, it will be yield 0. It will be checked. It was already present. No condition. So what will happen is, only unique XOR values are used. And what could be in the worst case? In worst case, as we have seen here, 1, 2, 3, 4. In the worst case, the largest possible value of any pair. The largest possible value of any pair will be 2 power m minus 1. What is m? M is the number of bits of largest element. In worst case, number of elements in set will be 2 power n minus 1 plus 1, which is 0, equals to 2 power m. Okay, and 2 power m for here, for it was 4, it was 8. 7 plus 0, it will be 8. So 2 power m is nothing but largest element star 2 possible, like the possible number. Okay, so time complexity will be, for finding pairs O of n square, and then plus O of 2 star just LE star n, because we will be, after finding all pairs and executing like inserting into the set, we will do its XOR with all the values of the original num array. As a result of n square plus just LE star n. During calculation of time complexity, we remove these constants. As a result, we do not consider 2 over here. Okay, and this is a valid and possible, what you can say, considerable time complexity. So let's implement it. Okay, so what will this? Also one more thing. If largest in is 1, then the number of distinct XOR triplet will be 1. So we will hard code it. Okay. Yeah. First we will find the maximum element. So that's what should be our approach. Find maximum element. If max element equals to 1, return 1. Else find number of bits and in next element, which is nothing but what it is, integer log n divided by log 2.0, and then return one addition. Why this addition? Because we want the upper value. For 2, the answer should be, what should the answer? I guess 3. For 4 it should be 3. For 2 it should be 2, I guess. Whatever it is explained in the last question video, so do check it out. For value of 8 it should be 4. For value of 4 it should be 3. So yeah, after finding out the number of bits, find, what we will do is we will find maximum element, and we will check if it is 1, we will simply return the maximum element is 1. And what we will do is find the number of bits, which is the number of largest m, and the largest element, which is int 1. Then what should we do? What it is, for loop to form, sometimes what happens is, even though you know the approach, you like sometimes it vanishes out of your mind. So as a result, if it was written somewhere, you can like directly get back to where you left it off. For loop to find pairs and store their XOR in set. Use set elements to do XOR with element sequence of nums and store in another set. Because if we store the final answer with the previous set, it will cause a conflict. If every time it was a new answer was created, the set would keep on growing. As a result, TLU will also be reached. And by chance it doesn't happen, the answers of the pairs and the triplets will be included, and we may get wrong answer. Return size of newly formed set. Okay. So let's do it. Find maximum element. We'll initialize it terms of 0 for auto and while. This is a for each loop. A STL dedicated STL tutorial videos will be dropping soon. Max LE equals to max LE and var. Okay. If max LE equals to 1, we return 1. LE equals to 1, return 1. Okay. If that's not the case, from friends and insert and add set. So declare a set. We'll use unordered set as well. Unordered set does not sort the elements but stores unique values and duplication. Okay. For int I equals to 0, I less than nums dot size I plus 1. For int j equals to I, because we cannot ignore two what same elements. Like here it is given that I and j can be equal and j can also be equal. That's it. We will insert in S1. What we will insert is nums I XOR nums j. Okay. Now we will iterate over set and do XOR with new answer F. Declare another set and set and S2. What is another set? Other set does not sort the elements, does not allow duplicate and erasure. Okay. Using for each loop once again. For S1. Keep a habit of adding comments to your code so that if you get stuck anywhere or want to make changes, you can go to that part, see what part is for what, and as a result it can be much easier to scale, change or debug. Okay. For int equals to 0. Now we will iterate over all the elements of nums. We'll insert in S2 where XOR nums of j, and then we return S2 size. just okay. Nums of here it should be nums of I. We are doing forming pair and inserting. Okay. Okay, all the test cases are passing. Okay. This was one of the optimal approach, but we will move to the more optimal approach. So what happens is, let me tell you. When we are using set, inserting time is for a login. So as a result, this adds extra time complexity. Okay, we can avoid it. How? What we have found out? What we have found out is that the largest element where it is. Huh. In worst case, the number of elements in the set would be 2 power m. So in the worst case, number of elements will be 2 power m. So why don't we create one vector beforehand so that we do not need to create a set. Create a vector of size 2 power n so that we do not need to insert in set. Okay, so let's implement that. Okay, now what changes we will to make is, instead of forming a pair and insert in a set, we will insert in a vector. Okay, so we'll declare a vector. Before that, we'll find the size. As z equals to, which is nothing but 2 power m. Okay, this is a method to find 2 power m. Int log n. Okay, yep. Log 2.0, it should be 2.2. I guess it is correct. And then we will plus 1. Okay, we will create a vector of bool just to make sure that this element has been formed as a result of XOR during a pair formation and output generation. Okay, what was the size, and by default we will give each a set. Another set is not being zero here. Okay, so this is 2 power m and declared as vector of size 2 power n and mark all as false. Why we are using bool? Because just to keep a track of which values have been formed in the pair as a result of XORs. Okay, here it would be nothing but v1, and instead we can use square brackets and mark them as true. Okay, now instead of iterating over set, we will iterate over vector and first check check if that value is found as XOR by pairs. If yes, it is. What we will do is, instead of declaring another set, we declare a variable answer. Okay, let's give it as answer equals to 0. Another set is not used. Instead of S1, we will iterating over V1. Here V1, and we'll check if that element is found. Here for each loop will not work because we will get the values and not index, and the value is it at the index in I equals to 0. I less than okay, I less than SL I plus plus. Okay, if b1 of I equals to true, it means it is formed. So we will do this operation. Okay, for int I. Okay, now what I am thinking is declare another vector of size as z to check or to a track of values formed by triplets. Okay, vector pool v2 size by default false. Okay, check if found XOR of found triplet is marked true. Let's first find the XOR, which is I. XOR I. What is I? This, which is still SL. If that is created or formed in pair, then we will do the XOR of I with numbers I. If v2 of XOR equals to true, that triplet XOR is marked true before we continue. Okay, else you can write it without else as well. If this was executed here, from here the loop will break and this statement will not be executed. Else v2 of XOR equals to true, answer plus plus. And instead of returning as answer. Let's check first. Maximum element is found. Here is one issue, and okay, and is okay, here it should be max LA. This way it is found. Okay, there is an error. So see, let's check 6, 7, 8, 9. The answer should be 4, but we have found 2. And same likewise. Okay, let's debug it. Find the size is equals to 2 power m. Okay, log of max LE plus 1. I guess here it should be as set plus 1. Okay, so I guess yes, here is the issue. Let's check now. Otherwise, there should not be any issues. Yep, as we predicted, what happened was here it was I and here also it was I. So due to that, there were collisions and conflicts. So yeah, we separated both the variables. Let's check now what is the time complexity. Yep, it has increased by several times, and for this also it is the same time complexity, but here some extra time will be taken to generate that what you can say vector space, and few time is being saved for not pushing into the set. So as a result, there is a remarkable decrease. Even if there was increase, but decrease proportion is more, and as a result, PC was input. Okay, and for the set time space complexity, this is also same because what you can see is description. Nums of y is 1500, so we can say that finding a next 2 power n will be very near to it, and as a result it can be considered as a constant space. So the space complexity would not be a major delta between them. So yeah, I guess that was helpful. We solved it using two approaches. One was using set and one was using a vector. Set had a few extra time for its insertion, while the vector just took extra time in its creation. And for the time complexity perspective, the second approach using vector was more optimized, and the space complexity wise, both are taking extra space, so both can be considered. So yeah, if you have any doubt, do let me know in the comments, and also the Excalibur link would be mentioned in the description as well. And yeah, do let me know any of the feedbacks or anything. Thank you.